one is evaluate the following definite integral. So, you know the definition of a definite integral. So, definite integral means an integral function which is defined between certain limits. Okay, so it is called a definite integral. So, here we have the question that is evaluate these definite integral. So, where the function is defined in a intervals. Okay, so the function is x minus 5 where x greater than 1. Okay, this a function is defined in two intervals. We have to first note that the given function the total integral limits minus 1 to 2 into these two parts, that is minus 1 to 1. Why? Because so here we have the two integral limits, two regions, x less than or equal to 1 and x greater than 1. So that is integral minus 1 to 1 f dx. So next we take 1 to 1 f of x dx. Why? Because here x greater than 1 means, so we have to take 1 to 2 also. So minus 1 to 1 x less than or equal to 1, the function is being here 2x plus 1. So we substitute here in first integral. And 1 to 2 means the function is x minus 5. We substitute. So by integrating these term by term, first integral limits are minus 1 to 1 and second integral limits are 1 to 2. Okay. So by integrating this, we get the value minus 3 by 2. Okay. Now, so here we split the limits. Okay. Next, evaluate the following integral. So integral minus pi by 4 to pi by 2 x cube sine power 4x dx. So uh, here the limits are minus pi by 4 to pi by 2. So whatever the limits, so here the function is x cube sine power 4x. So we have one formula. Already you know that integral uv or integral f of x into g of x. Like that we have to proceed. Um, Before going to that, so we have to check the function is a given function is either odd function or even function. So here the function is x cube sine power 4x. If we replace in the place of x minus x, the function, the given function is a odd function. Why? Because if we replace minus x in the place of x, so we get minus f of x. So the function is an odd function. So if the function is an odd function, so we have the properties of integrals. The integral becomes zero. Okay. Next, evaluate the following definite integral. Integral 0 to pi by 2 sin x by sin x plus cos x dx. So also the limits are 0 to pi by 2, finite limits, and the function is sin x by sin x plus cos x dx. So here also we have the property from the integrals. Integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. Okay. So we replace this. So by using the property, we replace x by pi by 2 minus x using this property in the given integral function. So we have integral 0 to pi by 2. So here we replace f of a minus x. Here our a is pi by 2. Okay. So sine pi by 2 minus x by sine pi by 2 minus x plus cos pi by 2 minus x dx. So what is sine 90 minus theta? Cos theta formula. Similarly, cos x by sin x plus cos x. So this is, so our given function integral is let it be I. This is equation 1, and after substituting or replacing x by pi by 2 minus x. So this is equation 2. By adding 1 and 2 equations, okay, we get 2i into integral 0 to pi by 2 sin x plus cos x by sin x plus cos x dx. So by cancelling, we get integral 0 to pi by 2 1 dx. So integral 1 dx is x between the limit 0 to pi by 2. So this is pi by 2. Next, so like that, different types of integrals we have to evaluate. Next, integral 0 to pi by 2 sine 2x log of tan x dx. So this is also of same model. So replace x by pi by 2 minus x from the given integral function, that is sine 2 of pi by 2 minus x into log of tan pi by 2 minus x dx. Again, by simplification, we get sine 2 pi by 2 is 2 to cancel sine pi minus x. Log of tan 90 minus x is cot x. Again, integral 0 to pi by 2 sine 180 minus theta is sine theta sine 2x. Log of, so we write cot is 1 by tan, that is tan inverse. So that is log of tan inverse x. So here we take log of some function, inverse function is, so we write it as a minus log of tan x. So completely we get minus here, that is minus integral 0 to pi by 2 sine 2x into log of tan x dx. So let it be I here, starting we'll take I here, we take I here. So we put minus I. So by adding taking these minus I to left side, we get 2i equal to 0 and I becomes 0. So what is I? So this integral becomes 0. Okay. Next. So these are the some different problems we will see in the integrals part. Next, partial differential equations. So first of all, we have to know the definition of partial differential equations. So can you able to hear me? Yes. Okay. So our second topic is partial derivatives. So first we have to know the definition of partial differential equation. So what is meant by partial differential equation? An equation which involves one dependent variable and its derivative with respect to one or more independent variables. It is called an partial differential equations. So here we see partial differential coefficients like fx, f suffix x, fy. So we know this. So fx means dou f by dou x, and this is the notation, okay? And fy is dou f by dou y. So here one important thing is there. One important main point is, while differentiating with respect to x, we treat suppose if f is a function of x and y. While differentiating with respect to x, we treat y terms are constant. Likewise, while differentiating with respect to y, we treat x terms are constants. Okay, and these are all the notations. So fx, fy, fxx, I mean dou square f by dou x square and dou square f by dou x dou y, dou square f by dou y dou x, and dou square f by dou y square, respectively. So it should be specially noted that, so we write dou square f by dou y dou x means dou by dou y of dou f by dou x, and dou square f by dou x dou y means dou by dou x of dou f by dou y. So like that we have to differentiate partially. Okay. Next, so in this topic we have a small questions. Hmm. That is, if z equal to f of x plus ay plus some phi of x minus ay, prove that. Okay. or uh, they'll ask a question like if z is a function, this is f of x plus ay plus phi of x minus ay, then find dou square z by dou y square. Okay, like that they'll ask. So first, partial differentiation with respect to x, that is dou z by dou x is f dash of x plus ay plus phi dash of x minus ay with respect to x means into 1 in both functions. Next, dou square z by dou x square is here, first of all, in this function, we have to eliminate the constants. I mean, not constants. We have to eliminate the functions, that is f and phi. So how now? Dou square z by dou x square equal to, so f double dash of x plus ay into. So again here we differentiate partially with respect to x a second time, that is second derivative, into 1 plus phi double dash of x minus ay into 1. So this is equation 1. Now dou z by dou y is, if now differentiate partially with respect to y, that is f dash of x plus ay into, here y coefficient a is a, so we write into a plus phi dash of x minus ay into, here y coefficient is minus a, so we write into minus a. Now taking a common, f dash of x plus ay minus of phi dash of x. So here, next we go for dou square z by dou y square. So likewise, we get a square dou z by dou y. So once again, we have to differentiate dou z by dou y with respect to y. That is, f dash of x plus ay into a is already a is there. Again, second time derivative. So we are doing second time derivative. So again, we write into a plus phi double dash of x minus ay into y into minus a. So taking a square common, f double dash of x plus ay plus phi double dash of x minus ay. So this term being a square into dou square z by dou y square. So from equation 1. Okay. So what is our left side term? Dou square z by dou y square. So if they ask dou square z by dou y square, so we have to show that a square into dou square z by dou x square. So in this last equation, in this last PDE, by eliminating arbitrary functions, so there is no f and phi. Okay, now so this is the partial differential equation by eliminating arbitrary functions, that is phi and f. Like that, if w, next question is if w equal to y minus z into z minus x into x minus y. So find the value of, so dou w by dou x plus dou w by dou y plus dou w by dou z. We have to find this. So in a simple way, we have to find. So that is, so while doing with respect to partial derivative with respect to x, yz terms are constants. So in this w function, we treat y minus z is a constant, and we have to differentiate with respect to x only. So we kept y minus z is a constant. Okay, and z minus x into x minus y. So we apply here UV rule. Okay, so like that, dou w by dou y. So while doing with respect to dou w by dou y, partial differentiation with respect to y, we treat x and z terms or constants. Similarly, dou w by dou z means we kept x and y terms or constants. Okay, so by adding these values, we get the answer 0. So this is a basics of PDE, and in this homogeneous function also will be there. So what is meant by homogeneous function? So let's see here. So f of x comma y equal to a naught x power n plus a1 x power n plus 1 y on a2 and y power n. So here we say that f of x comma y is a homogeneous function of degree n since the degree of each term is n. Okay. So coming to our definition, a function is said to be homogeneous function of degree n if the degree of each term in f of x comma y is n and is a real number. So in shortcut, I'll say that suppose there is a function. If the right side of the function, I mean right side expression contains equal powers. Okay, separately. So next, a function is said to be homogeneous function of degree or order n. Degree we say degree or order n in variables x y if f of kx comma ky equal to k power n into f of x comma y. So next, likewise we define in x y z variables also. Here x y z is also there. It's so this is called homogeneous example. So here we will see some one example. Let the function be x square plus y square. Now f of kx comma ky equal to. So we replace kx in the place of x, ky in the place of y. Okay. So from the definition of homogeneous, so we replace kx in the place of x and ky in the place of y and substitute taking k square common x square plus y square, so which is equal to x square into f of x comma y. So here we say that the given function is a homogeneous function of order 2. Okay. Next one is, so is it clear with the example 1 for homogeneous function? Yes, students. Is it clear with the example 1? Yes. Students, can you able to hear me?
Yes.
Okay. Next. So Euler's theorem or homogeneous functions. So what is the Euler's theorem is, if z is a f of x comma y is a homogeneous function of degree n, then x into dou z by dou x plus y into dou z by dou y equal to nz. Um, okay, like that, if u is a homogeneous function of xyz of degree n, then x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equal to nu. So what is the Euler's theorem says that, so this is the condition x into dou z by dou x if z is a function of x and y. And in second corollary, if u is a function of x, y, z, three variables. So in right side n into z and here it is n into u. Okay. So take one example. If f of x comma y is this root x minus root y by root x plus root y, then f of kx comma ky becomes, so what is that? Replace kx in the place of x and ky in the place of y. So taking root k in numerator common, similarly root k in denominator common. So by cancelling constants, um, so we write k power 0, okay, into x comma y. So the given function is a homogeneous function of degree 0. So by Euler's theorem, we also find x into dou f by dou x plus y into dou f by dou y equal to nf. So what is n here? 0. 0 into f is 0. Also, the notation for this left side term is x into fx plus y into fy equal to 0. Next, see second example. If u is a function of xyz, that is x by z whole square plus y by z whole square plus x by y, then u of kx comma ky comma kz equal to, okay, so we replace kx in the place of x and ky in the place of y and kz in the place of z, and taking constants common in both numerator and denominator, we get, by cancelling constants we get 1. So we write 1 as a k power 0 into the remaining term is given by u. Okay, so finally k power 0 into u. So therefore we say that u is a homogeneous function of degree 0 in x comma y comma z. So by Euler's theorem, x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equal to nu. So what is n here? 0. 0 into u is 0. So we need not to find separately, that is if suppose if they'll ask question for this question they'll ask find x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z. So we need not to find first we have to find, we need not to find dou u by dou x, dou u by dou y, dou u by dou z, and multiple with x, y, z, and total adding all these terms. So it is a lengthy process. So by Euler's theorem, we take this condition and substitute n value here. That is n into u. Okay. Yes. And some of the deductions from Euler's theorem. If z is a homogeneous function of x comma y of degree n and z equal to f of u, then, so these are the two deductions from Euler's theorem. Okay, you need not to prove. So just remember these two deductions from Euler's theorem. That is n into f of u by f dash of u and g of u into. So see left side term also, x square into dou square u by dou x plus 2xy into dou square u by dou x dou y plus y square into dou square u by dou y square equal to g of u into g dash of u minus 1. Okay, where g of u is also is n into f of u by f dash of u. See this example 1. So find x into dou u by x plus y into dou u by dou y. Okay, so if u is a function defined, so first of all we check whether it is a homogeneous or not. Okay, so how we will check it is a homogeneous function or not? So replace kx in the place of x and replace ky in the place of y. So by taking constants common in both numerator and denominator, by cancelling, we got constant k cube into u. Okay, again u is repeated here. So we get a k cube into u. So what is n value? 3. 3 means k cube, k power n. Here n is 3. So by simply by Euler's theorem, we write x into dou u by dou x plus y into dou u by dou y equal to 3u. So that is the question. Okay, 3u is the answer. Next, if u equal to function of x comma y comma z, so which is defined x square plus 4 plus y square plus z square whole power minus 1 by 2. Show that summation x into dou u by dou x equal to minus u. So first of all, we go for homogeneous function, whether it is a homogeneous or not, of which degree. So it is a homogeneous function. So by checking, by replacing kx, ky, kz in the place of x, y, z, we get the constant, k inverse, n is minus 1 here into f. So by Euler's theorem, we write x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equal to n. So here n is minus 1. That is minus u. Okay. So we write total summation of x into dou u by dou x also is equal to minus 2. Next, see the third one. If u equal to inverse of x cube plus y cube by x plus y, prove that x into dou u by dou x plus y into dou u by dou y equal to sine 2u. So if they ask question, find this term. Okay. So here u is not a homogeneous function. Why it is not a homogeneous function? So first of all, we write tan u equal to x cube plus y cube by x plus y. Okay, taking x square common, x cube common in numerator and x in denominator. We get x square into phi of y by x. So it is like some function f. So it is a homogeneous function of degree 2. Okay. By Euler's theorem, x into dou f by dou x plus y into dou f by dou y equal to 2f. We know this result. So that is x into dou by dou x of f is, what is f here? So first we assume this is our f color. So f means tan u. That is x into dou by dou x of tan u plus y into dou by dou y of tan u is equal to, so x into, what is the differentiation of tan u? Secant square u. Again into dou u by dou x plus y into secant square u into dou u by dou y is equal to 2 tan u. Next, take one on left side plus x into dou plus y into dou u by dou y is equal to, and getting secant square u in the right side denominator, 2 tan u by secant square. So we write tan is a sine by cos and secant square is 1 by cos square. By simplifying, we get sine 2u. Okay. And also, fourth question is also same process. So it is of degree 0. By Euler's theorem, x into dou u by dou x plus 1 into dou u by dou y equal to 0. 0 into that is 0. So if our alternate method is also there, if this is concept, this is a lengthy procedure. So dou u by dou x is differentiate pattern. So differentiate inverse and differentiation of tan inverse. So we get dou u by dou x is equation 1, and similarly dou u by dou y. So what is the question? Prove that. Okay, find. So they'll not ask you to prove that. So what is, so then what? Okay, so x. So now multiplying with x with dou u by dou x and y with dou u by dou y and adding, we get a 0 answer. Okay. So fifth question also same. Next. So in this PDE, there is a x differential also. What is that? For example, capital T is a function of p comma b, and also capital T is a function of p comma w. Okay, then we have the following results. That is, so for the first function, we write dt equal to dou t by dou p into dp plus dou t by dou v into dv. And the second function dt is equal to dou t by dou p into dp plus dou t by dou w into dw. This is equation 2. So dt is an exact differential of t. Okay, in general, if phi is a function of x and y, so we write d phi equal to dou phi by dou x into dx plus dou phi by dou y into dy. It is called exact differential of phi. Okay, remember that. And also chain rule of PDE. If z is a function of x and y, where x is function of t and y is psi of t. Next, if z is a function of x and y, where x is phi of uv and y is psi of uv, then dou z by dou x is here. Dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. Similarly, dou z by dou y equal to dou z by dou u into dou u by dou y plus dou z by dou v into dou u by dou y. So these are referred to as chain rule of partial differentiation. So the above rule can be extended to the functions of more than two independent variables also. If there are three variables, that is, if z is a function of uv, so we can also apply this chain rule. And the last one is total differential coefficient. So if z is a f of x comma y, where x is phi of t and y is g of t, um, then dz by dt equal to, already we know this. So in the differential form, the result can be written as du equal to, so dou u by dou x into dx plus dou u by dou y into dy. So we can also write this also. So du is called total differential of u. Okay. So this is all some basics of partial derivatives. Next, maximum and minimum. Maximum and minimum for function of a single variable. So already you know this very well. To find the maximum and minimum, so some procedure is there. Find f dash of x. First of all, a function is given. So find f dash of x and the equation is 0. Um, by solving that equation, we get the roots x naught and x1. Then find f double dash of x. I mean second derivative. If double dash of x at x equal to x naught is greater than 0, then f of x is minimum at x naught. If f double dash of x is less than 0 at x equal to x naught, then f of x is maximum. Similarly, we do this for our stationary points also. Okay. So for example, maximum and minimum of the function. So the given function is x power 5 minus 3x power 4 plus 5. What about f dash of x? 5 into x power 4 differentiation. So without differentiation and integration formula, so we cannot do even any single problem also. So we have to remember main basic formula. So 5x power 4 minus 12x cube. For minima, f of x equal to 0. So we get two stationary points. That is here 5x power 4 minus 12x cube equal to 0. That means x equal to 0 and x equal to 12 by 5. F double dash of x equal to. So again we have to initiate, that is 20x cube minus 36x square at x equal to 0. Okay. So we got points here. I mean two x values. At x equal to 0, f double dash of x is 0. So at this x equal to 0, the function is neither having maximum nor minimum. At x equal to 12 by 5, if double dash of x is, we value some positive fraction which is greater than 0. So what is the maximum condition, which is, so what is the minimum condition? If f double dash of x is greater than 0, after substituting that value, the given f of x is minimum at x equal to 12 by 5. Okay. So the minimum is by substituting this 12 by 5 in the given function, we get finally we get the minimum value. Okay. So this is so I explained this maxima and minima topic for function of single variable. Okay. For maxima and minima for a function of two variables also they'll ask. So this is the procedure. First dou f by dou x and we have to find dou f by dou x and dou f by dou y and equate to 0. We get the equation. By solving that equations we get the points sum a1 v1 a2 v2 and so on. And here we'll take notations L equal to dou square f by dou x square, m equal to dou square f by dou x dou y, n equal to dou square f by dou y square. So this procedure is for function of two variables, that is x and y. Okay. Next, third, here there is a three main points. If ln minus, after finding ln m, if ln minus m square is greater than 0 and l less than 0, then f of x comma y is maximum at a1 b1. After substituting that point in the given function, we get the maximum value. Okay, like that. If ln minus m square is greater than 0 and L is also greater than 0. See, the main difference is in maximum condition, in finding the maximum value, the condition is this ln minus m square is greater than 0 and L less than 0. Whereas in minimum, condition is ln minus m square greater than 0 and L is also greater than 0. Okay, so this is a main difference. If ln minus m square is less than 0, so how we will get ln minus m square? What is L? Second partial differentiation with respect to x. What is m? Second partial differentiation with respect to y. What is m? Dou square f by dou x dou y. So by product ln minus m square. So it is, if it is less than 0, by substituting the stationary points, what we are obtained at, suppose at a1 b1, ln minus m square is less than 0, the function is neither having maximum nor minimum. Okay, so in this case a1 b1 is a saddle point, so we call it as a saddle point. So the function which cannot get neither maximum nor minimum, so it is called a saddle point. Okay. If ln minus m square is equal to 0, it fails to have. Okay. Next, stationary points. We solve the equations dou f by dou x. First of all, we have to find dou f by dou x and dou f by dou y and equate to 0. We get the points a1, b1, a2, b2, so on. So those are called stationary points. So for example, so this is our equation, I mean function. So locate the stationary points. So if they ask find the stationary points of this function, so how we will find? So for maxima and minima, for both maxima and minima, first of all we have to do dou u by dou x and dou u by dou y should be equal to 0. We get two equations, that is equation 1 and equation 2. So by solving this, look above. So these two equations are similar equations. So we will take x equal to y also. So after solving these two equations, so how we will solve? Adding 1 and 2, we get x cube plus y cube equal to 0. And we apply the a cube plus b cube formula and it should be equal to 0. So from this first term, x equal to minus y. And from second, x cube minus 2x equal to 0. From equation 1, put x equal to minus y. Finally, x cube minus 2x equal to 0, x equal to 0 comma root 2 comma minus root 2. From the third equation, we have x equal to minus y. So y is also 0 minus root 2 plus root 2. Next, find out L, N, M. So L is dou square u by dou x square, N is dou square u by dou y square, and M is dou square u by dou x dou y. Now find out ln minus m square. It means L into n product minus m square. So we will check at these points. What are the stationary points here first of all? S 0 comma 0, root 2 comma minus root 2, minus root 2 comma root 2. These are the stationary points. So first we will check. So minus root 2 comma root 2, ln minus m square is greater than 0 and L is also greater than 0. Okay. So this function has minimum value. So it satisfies the minimum condition. What is the minimum condition? Ln minus m square greater than 0 and L is greater than 0. So here ln minus m square at the point minus 2 comma root 2 is greater than 0 and L is also greater than 0. The function has minimum value at this point, and substitute this point in the given function, that is x power 4 plus y power 4, the given u. So we get the minimum value. Okay, at 0 comma 0, ln minus m square is, we get the value 0. So it is not an extreme value. Okay, what is the meaning of extreme value? Maximum value or minimum value is a so if ln minus m square is becomes 0, so there is no conclusion. Okay, so there is no maximum or minimum point. Okay, again we will check another point also, root 2 comma minus root 2. So there may be exists maximum point also, maybe. And second question, find the minimum value of the given function. See here, this given function is a function of single variable or double variable, two variables. Let's respond in second question. The given function is given in single or two variables. Yes.
Single variable, ma'am.
Yes, very good. Single variable. So that is single variable. So simply we can solve. So first of all, given f of is this, we find f dash of x. See the question, find the minimum value for the function in the given interval. So the given interval also, that is minus 3 to 3. So the critical points are minus 3, minus 2, 3, and f of minus 3, f of minus 2, f of 3. So that is we got what we will have, minimum or maximum, minimum value. So in these three functional values, the minimum value is 28. Therefore, f of x has a minimum value at x equal to 3. Okay, is 28. Similarly, the maximum value of the function. So it is a single variable function. This question also in the interval 0 less than or equal to x less than or equal to 3. So here we will find f dash of x, and the critical points are 0, 1, 2, 3. Limits. So they mention the interval. So like so we get the maximum value. Here the maximum value is f of 3 equal to. Okay. Fourth question, last one is, so the maximum value of find out. So You can do this problem. Note down f of t e power minus t minus of e power minus 2t. So here f dash of t is 0. So we get t equal to log 4 base e. This is the maximum value. Okay. So up to this, your maximum or minimum value topic is clear over almost. So practice some of these basic problems and basic formulae. Okay. Um, so first of all, you have to see the question. The given function is in single or double. I mean two variables. If a function is in single variable, you proceed like this. So if the given function is in double variable, I mean two variables, so you will proceed. Your procedure is like this. Okay. Okay. Next. And the main points in these maxima and minima for function of two variables is remember these 3 points ln minus m square greater than 0 and l less than 0. It becomes the function has a maximum value and ln minus m square is greater than 0 and l greater than 0. The function has minimum value if ln minus m square is less than 0. So the function is neither maximum nor minimum. Okay. So these are the procedure for finding maximum or minimum for function of two variables. So these are the some of the examples of maximum and minimum. So is it clear, students? First of all, you have to remember all the basic formulae. Then only you can do problems. Yes. Is it clear? Yes. Yes, students give response to me. Okay, your voice is not clear, ma. So is it
Yes,
clear?
ma'am. No doubts.
Okay, ma. Okay. So if you have any doubts regarding these topics, you'll go through this material. So this video will be recorded. Is going to be recorded, so you can clarify some of the doubts. Okay. So and remember this Euler's theorem in this PDE and partial derivative. So the one main point is when differentiating with respect to x, we treat y term if function is a two variable. While doing partial derivative with respect to x, we treat y terms are constant, and while doing with respect to y, we treat x terms are constants. And in differential, I mean, an integral, mm, you have to remember all the integral basic formula. Okay. Okay. So shall we leave?
Yes, ma'am.
Yes. Okay.